Today we're going to pull on a thread. Not just any thread, but a thread in what we think of as the fabric of reality itself. We're diving into a pretty radical new idea in physics, one that suggests everything, and I mean everything we know, particles, forces, even space and time, might not be what we think they are. So let's get right into it. So let me just start with a crazy question. What if the most fundamental things in our universe, the particles, the forces, even the laws of physics themselves, what if they're all just shadows? Illusions, really. Just phantoms created by our own limited perspective on a much, much deeper reality. That's the question we're tackling today. You see, all of modern physics, pretty much, is built on these two gigantic pillars. And on the surface, they are incredible triumphs of human thought. But here's the problem. Deep down, they completely contradict each other. They're telling two totally different stories about how the universe works. And the simple truth is, they can't both be right. So to really understand why we might need a whole new theory, we first have to look at the cracks in our current ones. Let's really dig into the paradoxes, the deep issues that are right at the foundation of how we see the cosmos. Okay, so on one side, you've got Einstein's masterpiece, General Relativity. I mean, it is beautiful, it's elegance, and it describes the universe of the very big planets, stars, galaxies with just breathtaking accuracy. It tells us that gravity isn't really a force pulling things, but it's the actual shape of space-time itself being bent and curved. And then, on the other side, you have quantum field theory. This is our map to the completely bizarre, wonderful world of the very small, the subatomic realm of particles and forces that make up, well, everything. And make no mistake, it is the single most successful, most predictive theory in the entire history of science. And right here is where it all falls apart. In general relativity, spacetime is this dynamic, flexible thing, like a trampoline. But in quantum field theory, it's just a boring, static, flat background. In one theory, energy is geometry. In the other, it's all about probabilities and tiny packets of stuff. Physicists have spent decades trying to smash these two ideas together, and it just doesn't work. They're describing two fundamentally different universes. This huge disagreement, it points to a much deeper, almost philosophical problem. It's this idea of the mechanism versus the machinery. Think of it as the difference between knowing the rules of a game and knowing what the game pieces and the board are actually made of. Here's a good way to think about it. Our current theories, GR and QFT, they're like perfect architectural blueprints. They can tell you exactly how a building will behave, where the stresses are, everything, but they don't tell you what the building is made from. Is it brick, steel? We don't know. They perfectly describe the mechanism, but they tell us nothing about the machinery. They give us the rules of motion, but not the physical stuff that's actually doing the moving. And this forces a really profound shift in how you think. Physical laws, it turns out, don't govern reality. They don't command the universe what to do. They're just our descriptions of patterns that emerge from some underlying physical structure. The universe isn't following a rule book. The rules are a consequence of what the universe is. Okay, so if our current way of thinking is flawed, what's the alternative? Well, there's a new proposal that reframes everything. It suggests the universe isn't a collection of a bazillion different parts, but is instead one single thing. And the central idea is, well, it's breathtakingly simple, really. Reality is not made of particles. It's not made of fields or forces. Reality is one single unified object. And everything we see, everything we experience, is just a different behavior of this one single thing. So what is this object? Well, try to imagine a four-dimensional elastic material. 3 of those dimensions make up the fabric of space, which can stretch and bend and deform. But the 4th dimension is time. And this is the key part. It's proposed to be rigid, like a steel rod, allowing change to happen everywhere at once. So in this picture, a particle, like an electron, it isn't some tiny separate thing at all. It's just a stable, localized wrinkle in the fabric of reality itself. Now, a cool idea is one thing. But the real test of any new theory is, does it solve the old problems? So let's see how this model of a single elastic object might just elegantly untangle some of the deepest knots in physics. This is where it gets really good. So let's take the paradox of time. In this model, there are actually 2 kinds of time. First, you've got absolute time. That's the rigid 4th dimension of the machinery itself. But then there's relative time. That's what we actually measure with our clocks. And that's just a local emergent effect that we experience as we move through the fabric. See? The conflict was never real. We were just confusing the machinery with our perception of it. All right, here's one of the biggest unanswered questions in all of physics. General relativity tells us that energy curves spacetime. It's the whole foundation of the theory, but it never ever explains what energy is or how it actually performs this incredible trick. How does one thing affect the other?
And the answer this theory gives is just it's stunning. It says there isn't a separate thing called energy that goes around and acts on spacetime. They are the same thing. A particle's energy is the local curvature, the local deformation of the fabric. The separation we invented was an illusion all along.
And it doesn't stop there. This new machinery also has a totally wild alternative to dark matter. What if, instead of some mysterious invisible particle we can't find, the effects we see are caused by entire galaxies literally surfing on immense, slow-moving waves in the very fabric of reality? So here's how that would work. First, picture a galaxy as just this huge wrinkle in the fabric of reality. Now, picture that wrinkle being carried along, like a surfer, on an even bigger cosmic scale wave in that fabric. It's the gravitational pull from that underlying wave that we've been misinterpreting as a halo of invisible dark matter all this time. Okay, this is a powerful, really elegant idea. But right now, that's what it is, an idea, a conjecture. So how do we get from a compelling story to a testable scientific theory? Well, that is the next frontier. The path forward isn't with a bigger telescope or a bigger collider. It's with computation. The huge challenge is to create a digital model of this elastic fabric in a supercomputer, and then see if we can get it to produce stable, self-sustaining wrinkles, the very things we call particles. If we can do that, that would be the first real evidence for this whole new paradigm. The ultimate goal here is to build something you could call numerical particle colliders. So instead of physically smashing particles together, we'd be smashing these digital deformations together inside a computer to see if the model's predictions actually match the reality we see in our experiments. And this brings us right back to the beginning. For about a century now, we've been getting incredibly good at describing the shadows on the wall of the cave. This new perspective, it offers us a chance to finally turn around and see the machinery that's actually casting them. The only question is, are we ready for what we might find?